Okay, hi everyone. Let's continue. Last time we talked about the distance formula, right? So we were using the Pythagorean theorem. It's a right angle triangle, and then we have a squared plus b squared equals c squared. C is the hypotenuse. Okay, and then our distance formula, the d is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, x2 minus x1 is the change of x. y2 minus y1 is the change of y. So here we have right angle triangle. It's just like the Pythagorean theorem. Okay, so the midpoint formula. So this is another useful formula where we have the 2 points x1 and y1, x2 and y2. And then what is the midpoint? Well, let's look at the x coordinates. Okay, so we have x1 right here, x2 right here. And what is the midpoint? Well, average, right? You guys learn about average. So we have two numbers, x1 and x2, and then the average will be, we add those two numbers and then divide it by 2. So this is like average. We will get the midpoint of x1 and x2, right? That's the average values. Similarly, the y coordinates, we have y1 and y2. And then to find the middle values, we take the average. So we add the y1 and the y2, then divided by 2. So therefore, the midpoint formula is x1 plus x2 divided by 2. So that is the average of x1 and x2. And then the y value is y1 plus y2 and then divided by 2. So that's the average of x values and average of y values. So this is the midpoint formula. Okay, so far so good, everybody. If you can understand this, could you type 2 in the chat? Thank you. Okay. All right. So here are some examples. Do the points A, B, and C form the vertices of a right triangle? Okay. So let's plot the points on the xy plane. So we first draw the x-axis, and then we draw the y-axis. Okay, A is -8, -2. So x coordinates is -8. So we go to the left, a unit. 1, 2, 3, 4, 5, 6, 7, 8. So this is -8. The y coordinate is -2. So -2. And then we plot the point here. This is the point A. Okay? And then point B, 1, -1. So x coordinates is 1. We go to the right, 1 unit. So this is 1. And the y coordinate is -1. Okay, so the B is, oh, okay, let me see. Oh, okay. So let's change this problem a little bit, because the original problem is so obvious that the triangle is not a right angle triangle. Okay, let's change the point B to be 1 and -4. Okay, everybody, change the problem. So change the point B to 1, -4. Okay, so 1, -4. That is -4. So then the point B is right here. And then point C, 10, 19. Ooh, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. And then the y coordinate is 19. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Right here. So 10, 19. This is point C. And then we connect all the 3 points together. AC, AB. Okay, so AB and BC. Okay, yes, that's why you know why I changed the point B to 1-4. No, we're not. It could be possible that angle B is a right angle. Yes, everybody? Okay, so how do we know whether the point B is a right angle? There are so many different ways to solve this problem. One way we can use is the Pythagorean theorem. If the angle B is a right angle, which is 90 degrees, then we should have the sides by the Pythagorean theorem. We have the sides AB squared plus the side BC squared should equal to the hypotenuse. And you can see the hypotenuse is AC. That is the longest side of this triangle, right? So this should be true. So that's why we can check whether this equation is true. If it is true, then yeah, the angle B is a right angle. If this is not true, then the angle B is not a right angle. And from the picture, we're sure that angle C and angle A, they're acute angle, not a right angle. Then we can say this is not a right triangle. So this is one way. And if you learn vectors, so I'm not sure if you have learned vectors before in high school. Okay, so if you learn vectors and you learn about dot products, then you can show the vectors AB and the vector BC, the dot product is 0. Then they are perpendicular. Then we know angle B is a right angle. So that way is much faster and shorter. Okay, but because now we assume that you haven't learned vector, so we cannot use that method. So yeah, let's use the Pythagorean theorem. Last time we talked about the distance formula, right? So let's compute the distance AB, BC, and AC. So what is the distance AB? Well, the distance formula is square root of the difference of the x coordinates. So look at AB, the difference of the x coordinates. So therefore, we can use, by the way, which point do you use? Okay, so you can let A to be like x1, y1, and you let B be x2, y2, or you can let A be x2, y2, and then B be x1, y1. Okay, so you look at this formula, because it's the square, that's why the order does not matter. So you can use x2 minus x1 or use x1 minus x2. So we just need to have the difference of the x values, okay, and then square it. And then the difference of the y value and then square it, okay? Whichever comes first does not matter because this is the square, okay? Oh, that is the attendance alarm. Let me see. So let me look at the participants list. Okay, now today we only have 12 students. Okay, let's see. Okay, so that is the attendance. I know. Okay, so keep going. Okay, so come back here. So the difference of x. So we can use point B minus point A, right? So the x coordinates of point B is 1. The x coordinate of point A is -8. And then square. Plus the y coordinates of point B is -4. And then the y coordinates of point A is -2. And then we square it. So this is the distance formula. Okay, everybody? Let's keep going. 1 minus -8, that is the same as 1 plus 8. So 1 plus 8 is 9. Okay, so we have 9 squared. Plus, so here, -4 minus negative becomes +2. -4 plus 2 is -2. But -2 squared, it becomes 4. Right? Okay, or let's do it slowly. It's -2 squared. Okay. And 9 squared is 81. -2 squared. Negative squared become 1, right? Positive. And then 2 squared is 4. So therefore, this is square root of 85. So that's the distance between A and B. All right. We keep going. How about BC? Well, distance formula. Okay, now we use point B and point C. Difference of the x-coordinates. So the x-coordinate of point C is 10 minus the x-coordinates of point B is 1. And we square it. Plus the y-coordinates of point C is 19 minus the y-coordinates of point B is -4. Yes, don't forget the negative. Okay? And then we see, oh, now 10 minus 1 is 9. And we have the square. 19 minus -4. So minus negative, it becomes +4. What's 19 plus 4? Anyone type your answer in the chat?
23.
Thank you. Yes. 23 square. Ooh, this is a big number, right? Okay, so you can use your calculator. What is 9 squared plus 23 squared? So either can one of you like type your answer in the chat or say it. Take out your calculator. What's 9 squared plus 23 squared? What do you say?
529.
529. Oh, did you also add the 9 square?
81.
So this is, yeah, this is 81. So when we add them, what do we get? Is it 610? Right, everybody?
Yes, 610.
Thank you. Okay, so this is the distance between points B and C. Now let's look at AC. So AC is, we use okay, A and C. Now we use A and C. Okay, so we use the x-coordinate of point C, which is 10, minus the x-coordinates of point A, which is -8, plus the y-coordinates of C, which is 19, minus the y coordinates of point A, which is -2. Okay, and let's see. Well, 10 minus negative become plus 8. That's 18 squared. Plus 19 minus negative become plus 2. Ooh, that's 21 squared. Okay. What is 18 squared plus 21 squared? Everybody put this in your calculator. What do you get?
324.
Is that for the 18 square or the 21 square?
18 squared. 18 squared.
324. Okay, how about 21 square?
I got 441.
Thank you. So when we add them up together, what do we get?
765.
Thank you. Great. So now we're ready to plug in that equation, the Pythagorean formula, right? AB squared. So AB squared, AB is square root of 85, square it, plus BC squared. BC 610 square. Is it equal to AC squared? So square root of 765 and square. And you know square root and square cancel. So we're actually asking, is 85 plus 610 equal to 765? No, right? On your left hand side. That is 695. Of course, it's not equal to 765. So therefore, no. This is not a right triangle. Okay? So the answer is no. So that is example 1. If you can understand this example, could you type 1 in the chat? Thank you. Yeah, because right now I cannot see you in person. So if you have questions, please feel free to ask me. Okay? And if you want me to go over slower, also let me know. Okay? Because in class I can see your face and I know I can control the speed. But because now I cannot see you, so yeah, let me know. Okay. And by the way, we have the recordings in Blackboards. So if sometimes after you get home, you review your notes and you have question about it, please feel free to watch the recording. So my recommendation is after you go home, review your notes. And then you start to do your homework. So after you're done, use red pen to click the solution and correct your mistake. Okay? So our first homework assignment is due this Friday. Okay, so let's continue. Example 2. Find the center and radius of the circle with diameter PQ, where P is the point -3 and 2. So -3 and 2. And then Q is the point 4, -2. We want to find the center and the radius. Okay. So this is the circle. This is the diameter, right? And then we know, how do we find the center? Well, the center is the midpoint of the P and Q. Right? You see, the center here is actually the midpoint. And then radius of the circle. A radius is the distance from the center to a point on the circle. That's radius. Okay? So Let's find the point M. The midpoint is the center. Okay, so point M is midpoint formula. The average of the x coordinates and the average of the y coordinates. A typical mistake is students might put this as negative because they're confused with the distance formula. Distance formula, yeah, we have negative because that's the difference between the x values and the y values. So we have negative. But for midpoints, we are talking about the average. That's why we add those two numbers and divide it by 2. Okay, so let's see. x1 is -3, the x coordinate of point P. And then x2, the x coordinate of point Q is 4. And then divided by 2. The y coordinates of point P is 2. The y coordinates of point Q is -2. And then we divide it by 2. Alright, so do you see -3 plus 4 is 1? So we get 1/2. And 2 plus -2 is actually 0. 0 divided by 2 is 0. So our point M is 1/2 and 0. And kind of makes sense because you see this from the graph. Oh, this is exactly 1/2. It's a point between 0 and 1. In the middle of 0 and 1, so we know this is 1/2. By the way, in an exam, the picture might not be given. Okay, so you cannot just look at the picture and guess this is 1/2 and 0. So we actually need to compute that and show your work in order to receive full credits for this problem. All right, let's keep going. So we have the midpoint. That is the center of the circle. And now let's compute the radius. So radius, so there are two ways to compute the radius. You either use the distance formula between point M and Q, or you can use the distance formula from point P and Q. That will give us the diameter. And we know distance is the diameter divided by 2, right? So that's why we have two ways to compute that. Which way is easier? Because the point M has 1/2, I would try to avoid working with fractions. So I would prefer to compute the distance between P and Q. Then I work with integers. So that I think that's easier if I work with integers. Okay, and then I divide it by 2. So let's do that. Okay, so of course you can compute the distance between M and Q. So you just work with the fractions. That's okay. All right, so PQ. Okay, so PQ, the distance is the difference of x coordinates. Okay, so point Q, the x coordinate is 4, minus point P, the x coordinate is -3. Square it, plus the y coordinates of Q, which is -2, minus the y coordinates of P, which is 2, and square it. Alright, it's the square root of 4 minus negative become plus 3. Sorry, 4 plus 3 is 7. So 7 squared plus -2 minus 2 is -4. -4 squared right here. So 7 squared is 49, right? 4 negative squared become positive. 4 squared is 16. So 16 plus 49 is 65. Right, everybody? So PQ is the diameter. Then radius is 1/2 of the diameter. Therefore, it's 1/2 of square root of 65. Okay, so this is the radius. And now we know the center. And we know the radius. We can actually write down the equation of circle. Okay, so what is equation of the circle? Okay, so if a circle has center A, comma B, and radius R, okay? So let's say a point on the circle is xy. So a point on the circle, let it varies. Okay, so the point on the circle is xy. What is special thing about the circle? Well, the special thing about the circle is the distance between the points on the circle and the center is always equal to the radius, right? So for circle, the distance between the points on the circle and the center is always equal to the radius. So what's the distance between the points? Well, the point on the circle is x comma y, and the center is AB. Therefore, the distance between the points on the circle and the center AB, use the distance formula. That is the square root of x minus a squared plus y minus b squared. The distance is always equals to the radius. And we square both sides. We get x minus a squared plus y minus b squared equals r squared. This is the equation of the circle. Okay, so keep this formula in mind. And yeah, I already tell you how to derive this formula. You let the center be AB, the radius is R, let the points on the circle. So your point is moving. Yeah, it's moving on the circle. So that's why you use XY for the variables. And you know the distance between the point on the circle and the center is the radius. Therefore, you use the distance formula to derive the equation of the circle. And now come back. In our case, our center is 1/2 and 0. So we plug in x minus a is the x coordinates of the center, which is 1/2, plus y minus b is the y coordinates of the center, which is 0, equals to r squared. R is 1/2 times square root of 65 squared. Let's simplify it. So we have x minus 1/2 squared plus y minus 0 is y squared. And now 1/2 squared becomes 1/4. And square root of 65 square roots and square cancel. That's why we have 65/4 on the right hand side. So this is the equation of this circle. Okay, so yes, let me see. Do you have a question?
Yeah. Can you please repeat how do you get 64/4?
Sure. So we have the radius. This is the radius 1/2 times square root of 65. We square it. Therefore, we have 1/2 square and the square root of 65 square. So last time we said if you have multiplication or division, you can distribute the exponent, the power. But if you have sum or subtraction, then we cannot distribute the power. Okay, so therefore, this is 1/2 square is 1/4, and then square root and square cancel. So we have 65. So that's why I just put them 65/4.
Okay, okay, thank you. That makes sense now. Thank you.
Oh, you're welcome. Yes, very good. If you have questions, feel free to unmute and ask me. Mhm. Okay, if you can understand example 2, could you type 2 in the chat? Thank you. Great. So this is the worksheet of geometry. Okay, so we finished this worksheet. Let's look at the new one. Okay, so I have printed out this worksheet for you, but because I cannot see you today, I will bring it to you on Fridays. So for now, you can either like take notes on a piece of paper, and then on Friday after you receive the worksheets, then you can copy your notes down. You can maybe just attach your notes to that worksheets. Yeah. Okay. So linear equations. How many of you have learned linear equation before? If yes, could you type yes in the chat? Linear equation. Have you learned linear equation before? Okay. So I have 4 of you have learned that. 5. Okay. So it's good that you have learned this. So when we go over them, it's kind of a review. Okay. If you have questions, please feel free to let me know. Okay. Graph and their intercepts. An order pair AB is a solution of an equation in variables x and y if the equation becomes a true statement when A is substitute for x and B is substitute for y. We say AB satisfy the equation. So AB, they are numbers. So you plug in x equals to A, the number A, and you plug in y equals to number B, and see if it satisfies the equation. Satisfy the equation means you have an equation, you want to check whether the left-hand side equals to the right-hand side. If yes, then this is true, right? Okay, so example 1. Consider the equation. So here we have a linear equation. So linear means the power of x is 1 and the power of y is also 1. Yeah, so this is a linear equation. We want to determine if each of the following order pairs is a solution of the equation. Okay, so let's see the first one. Okay, the x coordinate is -2 and the y coordinate is 1. Therefore, we plug in x is -2 and y is 1. So look at our equation. On the left-hand side, we have -2 times x. So we plug in x is -2 plus 5 times y. Y is 1. And is it equal to 9? Let's see on the left-hand side. -2 times -2 is 4. 5 times 1 is 5. Is it equal to 9? Yes! Right. So this point is a solution of the equation. And linear equation represent a line. So this means this point is actually on the line. So point is on the line. Okay. So this is part A. Let's continue with part B. So x is 1 and the y is 2. We plug in -2x. X is 1 plus 5 times y. Y is 2. Is it equal to 9? let's see, on the left hand side, -2 plus 2 times 5 is 10. Is it equal to 9? -2 plus 10 is 8. 8 is not equal to 9. So no. So what does that mean? That means the point is not on the line. Okay, the point is not on the line. Well, that is part B. Now part C. Okay, x is 3 and y is also 3. We plug in -2 times 3 plus 5 times 3. Is it equal to 9? -2 times 3 is -6. 5 times 3 is 15. Is -6 plus 15 equal to 9?
Yes.
Yes. Yeah, right. Very good. So, this point is also on the line. Okay. So, other examples you might have like other equations. Okay, you can have like maybe x squared plus 2y equals 5. Okay, this is an equation. Or x times y squared equals 2x minus 1. This is another equations. So not only linear equation, you can have other equations. And to check whether a point, a order pair is a solution of the equation, we just plug in the x and the y and see if the left hand side equals to the right hand side. All right, so continue. We can describe solutions of an equation by plotting points on a coordinate system. The graph of an equation in two variables is a set of all points that corresponds to all solutions to the equation. Okay, so for example, y equals x squared. If you have learned this before, this is the parabola. Okay, and how do you write on the graph of this parabola? Well, you have your x coordinate and y coordinate. You plug in some points. Let's say we plug in x is 0. Well, the y is x squared, so 0 squared is 0. Then we pass through the origin 0, 0. If we plug in x is 1, we get 1 squared is also 1. So we have 1, 1 here. And we plug in 2, 2 squared is 4. So 2 squared is 4. X coordinate is 2, and then the y coordinate is 4. So we have this point. How about we plug in -1? Well, -1 squared is 1, right? So -1 squared is 1. And then how about -2? -2 squared is negative become positive. 2 squared is 4. So we have -2 and 4. Then we connect the points together. So we get the graph of this equation y equals x squared. Okay, so this is the graph. We can put points to the coordinate systems and connect the points smoothly to get the graph. Okay, x-intercept. X-intercept of an equation is found by setting, okay, for example, let's say we have this line, okay, this line. We want to find the x-intercept. So this is the x-axis, this is the y-axis, this is the origin. To find the x-intercept. Well, what is special about it? Well, the x-intercept is on the x-axis. Well, on the x-axis, do you know on the x-axis that the y-coordinate is 0? Okay, so the x-axis is like a horizontal line. The y-coordinate is 0. So to find the x-intercept, we set the y equal to 0. And we want to solve for x. Okay. And then how about the y-intercept? Well, the y-intercept, the y-axis, that corresponds to x is 0. Yeah, and the y-axis corresponds to x is 0. Therefore, the y-intercept here, we're setting x equal to 0. And we solve for y. Okay. So yeah, once you draw the picture, then you can see, so this point, oh, I should use orange color for this point. You see, x, let's say this distance is a, then this x-intercept, the x-coordinate is a, but the y-coordinate is 0, right? The y-coordinate is 0. And then for the y-intercept, let's say this distance is b, then the y-intercept, the x-coordinate is 0, and then the y-coordinate is this distance b. So therefore, we can get the x-intercept and y-intercept. Okay, continue. If an equation can be written in the form ax plus by equals c, where a, b, c are constants, then the graph of the equation is a line. So a line, okay? Example 2, find the x-intercept and the y-intercept of the following equations and sketch its graph. Okay, so to find the x-intercept, we set the y equal to 0 and we solve for x. So we set the y equal to 0. Okay, look at this equation. We plug in y is 0. So replace y by 0. We get 2x minus 3 times 0 equals 12. 3 times 0 is 0, so 2x equals 12. Both sides divided by 2. We get x equal to 6. Be careful. X-intercept is a point. So the x-intercept is the order pair. The x-coordinate is 6. The y-coordinate is 0. Don't just say x equals to 6. X equal to 6 is actually a vertical line. So that's the vertical line 6 right here. So this is a vertical line x equal to 6. Okay? It's not a point. X-intercept is a point. That's why it's an order pair with the x-coordinate is 6 and the y-coordinate is 0. Okay, so be careful with that. And continue. Y-intercept. So we set the x equals 0. And we solve for y. Okay, so x is 0. 2 times x is 0. Minus 3y equals 12. Okay, so 2 times 0 is 0. So 3y equals 12. Both sides divided by negative 3. We get y equals, what's 12 over negative 3? Any of you type your answer in the chat?
-4.
Thank you. Yes, y is negative 4. So our y coordinate is, it is a point. With the x coordinate is 0. The y coordinate is negative 4. Okay, don't just say y equals negative 4 because this is a horizontal line. Okay. Now, we sketch the graph. Okay, so x is 6 comma 0. So 6. Let's put the 6 here. By the way, when you draw the graph, you don't have to put a lot of bar there. You can just put a bar and say that is 6. Okay. And then negative 4. So 6 comma 0 right here. 0, negative 4, negative 4. Okay, negative 4 right here. So put that point. And 2 points can fix a line. So we just connect them. So this is the line. Okay, this is example 2. If you can understand example 2, could you type 2 in the chat? Thank you. All right, let's keep going. Example 3 is similar to example 2, except the equation is more complicated, but you can simplify the equation first, right? So let's simplify it. Combine the like terms. Negative 4, distribute it. Negative 4x. Negative 4 times 2 is negative 8. Plus 2y minus 6 equals 0. Okay, combine the like terms. So negative 4x and negative 8 and negative 6 combined together, it becomes negative 14 plus 2y equal to 0. In order to get the general form, so this is the general form of a line. You see, we move all the constants to the right hand side. So we move the constant to the right hand side. So we add 14 on both sides. We get negative 4x plus 2y equals 14. Can we simplify further? Can you see the coefficients? The negative 4 is the coefficient of x, 2 is the coefficient of y, and the right hand side is 14. They are all even, so they are divisible by 2. They have a common factor 2. So to simplify it, maybe it's better to divide it by 2 on both sides. Okay, so divided by 2 on both sides, we get negative 4. So divided by 2 on both sides, okay? And because the left hand side you have a plus, that's why you need to divide it by all the terms by 2. Negative 4 divided by 2 is negative 2x. 2 over 2 cancel. We get y. And 14 over 2 is 7. See? We have simplified it. Now we find the x-intercept. So x-intercept, we said y is 0. Y is 0, we get negative 2x plus y is 0 equals 7. Okay, so if you know y is 0, then you don't need to write at 0, because at 0 is just like you don't, yeah, it's nothing, right? So negative 2x equals 7. Solve for x. So both sides divided by negative 2. We get x is, we can move the negative in front. So negative 7 over 2. So the x-intercept, x-coordinate is negative 7 over 2. And the y-coordinate is 0. Okay, make sure you know x-intercept and y-intercept, they are points. They're not vertical line or horizontal line. Okay, so use the order pair to denote it. Y-intercept, we set the x equal to 0. Well, negative 2 times x is 0 plus y is 7. Negative 2 times 0 is 0, so we get y equals 7. Okay, y-intercept is points. X-coordinate is 0. Y-coordinate is 7. Yay! So we can draw the line, right? X-coordinate, negative. So negative 7 over, sorry, something wrong with, okay, negative 7 over 2, right here. And the y-coordinate is 0, 7, 7 right here. So we connect those 2 points together. So this is the line. Okay, perfect, right on time. If you can understand example 3, could you type 3 in the chat? Thank you. Have a nice day. Our homework is due on Friday in Blackboards. Okay, if you have questions, feel free to let me know. Email me, and then today, because we're at home, so if you want to like see me virtual, we can also like set appointments, email me, and then we can go to the our virtual classroom to meet. Okay. Have a nice day. Oh, Colin, you have questions?
So so are we all so is it always gonna be setting x or y to 0? Is it most part that we get always like x set x equals to 0 or set y equals to 0?
To find the x-intercept and y-intercept, yes, we do that. Okay.
Oh,
But
okay.
if the problem just, sorry.
Oh no, I was just saying okay to your answer.
Yeah. So this way, the problem asks us to find x-intercept and y-intercept. Then we have to find it. But if the problem just say grab the line, well then you don't have to find the x-intercept or y-intercept. You can use other methods. Next class, where we talk about the slope-intercept form, we can draw the line by first finding the y-intercept and then look at the slope to see run and rise to find another point and then draw the connect those 2 points to graph the line. So it depends on the problem.
Okay, yeah, thank you. And
You're
is the
welcome.
exam this Friday, or was the first exam this Friday, or when was the first exam?
The first exam.
Yeah, when was that? Was it this Friday or was it?
Oh no. The first exam is after we finish chapter 1, so it's
Oh,
long time. Yeah,
oh,
this
oh. Okay, what was
this
this Friday? What they what was
this
this Friday? And was that the homework or
yeah, just the homework.
just the
So
homework?
this
Oh, okay,
Friday, just the homework. And
okay,
then next Friday, you have also homework 2. And then the February 10th, you have quiz 1. So homework
okay,
and quiz 1. And our exam is February 22nd, after we finish chapter 1.
okay. And the homework is in the is it- it's in the book, right? It's in the book. The problem
Yes, in your
book.
book. Right. But if you don't have your book, I have scanned the homework problems. So this is
Okay,
your homework, and that's the solution. And this is the scans of your homework questions. So
okay,
yeah, P.2 is right here. P point, yeah. So you
okay. Thank you.
can put that. Yeah.
Okay,
Okay.
thank you.
And you
You have
upload your homework in Blackboard. So you
okay,
first use pencil to finish it, and then once you click the solution, use red pen.
okay,
If you're correct on the problem, put a check mark next to that problem. If you have mistake, cross your mistake and write down the correction next to it.
okay. Thank you so
Hmm.
much. You
You're
have a good day.
welcome. Have a nice day.
Yep, you too.